This is section 7.7, trig equations. So now we're actually solving for things. We're going to say things like theta equals pi over 6 and pi over 3 and pi over 4 and those kind of things. And just it is a little different from inverse trig, which is 7.1.7.2. That we also said angles, but this has a very specific interval, 0 to 2 pi, which means I can't go negative and I can't go over 2 pi. Okay, so if you can remember a little bit of 7.1.7.2, we had some negative angles like negative pi over 6. In this one, we cannot have any of that happening. All right, so let's just start with a fairly straightforward one. This says solve the equation cosine theta is 1/2, so hopefully you're thinking 30, 60, 90, on the interval 0 to 2 pi. So let's draw this one out. We may not draw every single one, but let's draw this one out. All right. Now this has nothing to do with inverse cosine, so we're not going to x anything out. We're just going to say cosine can be positive here and here, first and fourth. So this is more of the all students take calculus idea. And if the adjacent's 1, hypotenuse is 2, then here's what my triangles look like. And then that reference angle is a 60, but let's call it pi over 3. All right, now here, let's make sure we follow the interval. 0 to 2 pi means your answer has to be a positive angle. So my theta will be pi over 3. That's the one in the first quadrant. And then the one in the fourth quadrant is going to be called 5 pi over 3. All right, so solving on the interval 0 to 2 pi means I'm going to give all the answers positive answers that make cosine 1/2. Now, part B is still relating to the same question, but the directions are slightly different. It says find all of the solutions, meaning forever and ever to infinity. Okay, so now I'm not saying you have to stop at 2 pi. So you could start a list, right? You start listing them out, continue adding 2 pi's to them. But let's talk about a little new notation here. So I know that theta can be pi over 3, and I know theta can be 5 pi over 3. Now, when I go 2 pi around the circle, so if I were to add 2 pi to this, I'd get another solution, right? And if I add 2 pi to this, I get another solution. And then 4 pi and 6 pi and 8 pi. So I just continue going around the circle forever. Now, the way we would do this without listing all of them would be to k on the end, okay? Where k is an integer, meaning it might go once around, twice around, 3 times around. Whatever k is, you could go that many times around. Now, part C says, give me 6 solutions. So not 2, not all, but 6 solutions. So if I look at my k, so if I start with, let's just start with pi over 3. If I add 2 pi to that, all right, or 6/3, let's say, then I get 7 pi over 3. All right, so that would be another one. And then if I take my 5 pi over 3, all right, and I add 6/3 to that, I get 11 pi over 3. And if I keep going along that, so just adding 6/3 on every time, I get 13 pi over 3 for this one, and I get 17 pi over 3 for this one. So there's 6 solutions. Now let's look at a medium one, something that's a little bit tougher. If I look at this one, before you start any 0 to 2 pi business, make sure you get the trig all by itself. Get sine theta all by itself. So my algebra tells me if I want to get sine theta by itself, I'm going to subtract the root 3 and divide by 2. All right, so here we go. Here's my circle. Sine negative would be here and here, third and fourth. Again, this is the all students get calculus. And if I put my numbers on, they look like this. All right, so I have another pi over 3 reference angle for both of these. Now remember, it's got to be 0 to 2 pi if it says it in the directions. So my thetas have to be positive. So I'm going to call the one in the third quadrant, I'm going to call that 4 pi over 3. And I'll call the one in the fourth quadrant, I'll call that 5 pi over 3. So there are my 2 answers if I have to go 0 to 2 pi. Then part B says find me all the solutions. So now let's practice. We have 4/3 of a pi. We have 5/3 of a pi. And if I continue going around and around and around the circle forever, I call it 2k pi, or 2 pi k, however you want to do it. That's all the solutions forever. Now the trickiest ones are when you start messing with theta. So look at number 3. It's not just 1 theta anymore, now it's 2 theta. Okay, so what we do is first we pretend that it's 1 theta. Okay, so when is sine a half? Okay, so without drawing the circle, hopefully you can see. Sine is going to be a half at pi over 6 and also at 5 pi over 6. And if you need to see that, draw the circle out, but hopefully you trust me on that. Okay, now, the instructions say 0 to 2 pi, right? Which, if it were 1 theta, I could just stop. I'd be all done. But since it's 2 theta, we have to do a little more algebra on these. So now I'm going to sneak my 2 back in. 2 theta, 2 theta. Okay, so it's not 1 theta anymore, now it's 2 theta. And as soon as you change your theta, now we're going to consider the 2k pi on the end. And you might be thinking, well, you can't go over 2 pi, but look at that red 2 on the left. I'm about to divide by 2. And when I do that, you should see we're going to get some more answers. Okay, when I cut both sides in half, okay, so if I divide everything by 2, that pi over 6 becomes pi over 12. So now I'm in twelfths of pi's. And that 2k pi becomes 1k pi. All right, if I do the same thing on the bottom one, this becomes 5/12 of a pi and 1k pi. So now let's start our list. There might be a few on these, maybe not just 2 anymore. So I have a 1/12 of a pi, and I have 5/12 of a pi. Okay, now I'm adding 1 pi on. And if I'm in 12s, why don't we consider it as 12/12 of a pi? All right, same thing here, 12/12 of a pi. Okay, so now if I take my 1/12 and I add 12/12, I'm at 13/12, which is not over 2 pi, so it's okay. And if I do the same thing with 5/12, add 12 on, I get 17/12. Okay, whoops, 12ths on that one. And that's still not 2 pi. And you might see that it goes over, but let's just try one more. Okay, so if I take my 13/12 and add 12/12, I have 25/12 of a pi, which is over 2 pi. So since I have to stay on the interval, I'm not going to count that last one, and I'm only going to box these first 4. All right, I want you guys to try number 4. It's very similar, but this time it's cosine, and it's a -1/2. So solve for your theta first, then make it 2 theta, and add your 2k pi on. All right, see what you can do. All right, let's do number 5 here together, though. All right, so first thing to notice, tan and cotan have period 1 pi. Remember their graphs? So sine and cosine, we add the 2k pi. Tan and cotan, we're only going to add 1k pi. Okay, and it's because of the period of it. All right, so let's tackle this one. Solve this equation, again, on the interval 0 to 2 pi. So we have to stay under 2 pi, and we have to be positive. And this one says tan of theta minus 1/2 is 1. All right, so again, I'm going to act like this is just theta for now, and I want to find out when it's 1. So it will be 1, leave a little space here, at pi over 4, right, because that's your 45, 45, 90. And it will also be 1 at 5 pi over 4. So it's a 45, 45, 90 in the third quadrant. All right, so now, if it were just 1 theta, we'd be all set. We'd stop, no problem. But it's not just 1 theta. It's theta minus pi over 2. All right, theta minus pi over 2. Theta minus pi over 2. And now, since it's tangent, we add 1k pi, not 2k pi's. All right, so if I do this, okay, now I know I have to add the half theta over. Now your algebra, remember, when you're adding and subtracting, you can only add like terms. So that half theta on this one can only join the pi over 4. It can't join the k pi because it doesn't have a k in it. So we're adding a half to a fourth, so we get 3/4. And then we add the k pi. Same thing over here. Adding a half to 5/4, we get 7/4. And adding the k pi. All right, now we're ready for our list. But if you want to think about 1k pi as 4/4 of a pi to make your adding easier, we can do that. Okay, so here's our list. We know 3/4 of a pi works. we know 7/4 of a pi works. Now, if I add 4/4 to 3/4, I get 7/4. Well, I already wrote it once, so don't worry about it again. If I add 3/4 to 7/4, I get 11/4. What's wrong with this picture? Well, 11/4 is too big. So I can stop at these two answers. All right, so I want to leave number 6 blank. Let's do it in class together. It's a little bit tougher, but I want to do one on the calculator with you guys. Okay, so if you don't already, grab your calculators or just trust me when I do it, however you want to do that. And then we're going to do number 6. Okay, here's what's confusing about the calculator. In order to use a calculator, we have to use the inverse button, right? So, for instance, for number 7, to undo cosine, we need the inverse cosine. Well, inverse implies restricting quadrants. So if it's an inverse cosine, technically you should be thinking like that, right? But it's not really an inverse question. So 1 through 6 that we just did, they're not really inverse questions. But we just need that special button on the calculator to get us going. All right, hopefully that makes a little bit of sense. But I'll show you in class again if we need to bust out the calculators. Okay, so let's just try this real quick. Solve for cosine theta is 0.6 on the interval 0 to 2 pi. Now, if we're using the calculator, it's going to spit out decimals. So I'm going to rewrite the interval as 0 to 6.28, which would be 2 pi. So then I know my decimals. I know where to stop with my decimals. Okay, so I'm thinking cosine. And again, it's not inverse. It's all students take calculus for these. And cosine can be positive here and here. All right, so if I hit the inverse cosine button, so on my calculator, I'm going to go inverse cosine of 0.6. And it will spit out 0.93. Okay, now when we're talking about radians, 0.93 is kind of hard to wrap our head around. So why don't we look at this circle in a little different way? We know where 0 is, and we know where pi over 2 is. But in decimals, pi over 2 would be 1.57, and pi would be 3.14, and 3 pi over 2, I don't know, 5 point something, I can't remember. And then back to 2 pi would be 6.28. So 0.93, this number that our calculator just gave us, would be in the first quadrant. That means that this reference angle would be 0.93. And since the reference angle can't change, this one down here in the fourth quadrant also has a 0.93 reference angle. So I know one answer because the calculator told me so, 0.93. Now the other answer, remember we have to do a positive angle. So we have to go all the way around like this. So theta, the second theta, will be whatever 6.28 minus the 0.93 is. And if we do it correctly, we get 5.35 as our second theta. Now remember, if I have to go 0 to 6.28, that's about there, right? Okay, hold off on number 8. I'll show you guys how to do that one on the calculator in class tomorrow.